absentee.
Liberty. Thank you.
Thank you. Yeah.
All right. So there's painting and hot chocolate Tuesday, February 18th, which is tomorrow, in the Lark's Nest, 7 to 9 p.m. Thank you to all the WAs and CAB for doing this.
Yeah, all right. Next, Wednesday worship is every Wednesday in the Kime basement at 9 p.m. Look for an email from Audrey with the up-to-date information. Come as you are, all are welcome. Next.
Calling all writers to submit a piece to the Acuity Annual Writing Contest. Pieces are due by February 23rd. Win a gift card and become a published writer. Look for the poster to learn more about how to enter. Also, maybe writing isn't your thing and you have artwork. Present your creative pieces to Joshua Cross to be featured into the magazine. If you have any questions, reach out to Miriam Barton or Joshua Cross. Next.
Spring break is coming up. The dorms will close on Saturday, March 15th at 9 a.m. and then reopen March 22 at 6 p.m. unless a student is otherwise approved by Student Life. Please contact Jacob Fetters or Natalie Ladd if you have any questions about this. The dorms will be closed. Next.
This is just a friendly reminder to check your email. There are and will be important announcements from the registrar about the academic calendar and from Student Life about housing for next year and the summer. And now some announcements from athletics.
What's the best way to store your dad jokes? In a dada base. All right. The track teams participate in the region indoor track meet this Saturday at Pittsburgh, Kansas. Men's basketball team defeated Fort Scott in double overtime on Saturday, 88-82. Trent Thompson had 27 points and 21 rebounds to lead the Larks. The Larks are scheduled to play away twice this week, at KCK on Wednesday and at Neosho on Saturday. Women's basketball lost to Fort Scott 49-76. Ashley Williams had 9 points and 9 rebounds. The women host McPherson Reserves tonight and then travel to KCK and Neosho later in the week. Baseball won a game on Friday over Cedar Rapids Community College 10-8. Lucas Dunn had 3 RBIs in the game. The baseball games for tomorrow and Wednesday have been canceled due to weather. We are scheduled to host Metro Community College this Friday and Saturday. Softball is playing today in Oklahoma at Southern Nazarene University at 1 and 3. They also play this weekend. Esports, Overwatch plays Carroll College on Wednesday. Fortnite plays in the Builds tournament. Super Smash Brothers plays Texas A&M on Tuesday, and Valorant plays UT Dallas tonight. You can watch those games on Twitch.
It is my honor to introduce to you Dr. Kyle Miller-Hessed, who I was going to ask how many years. I'm going to make a guess and it'll be wrong. This is year 10. Yep, I was going to guess 12, so yeah. So that's kind of an anniversary year. I have always deeply, deeply admired Kyle's commitment to science and to this college and to you all as students. There's teaching and then there's also deep, deep care. And I've seen both in that in you, so thank you very much. Let's please give Kyle our attention. Yeah.
Thank you for that kind introduction. So a lot of interesting things to talk about, things to try to make sense of. We'll see what we can do. I think this is the wrong, I think what we want is the Google Doc that was shared. Give us a minute. It had been up earlier. Yeah. So the question that more or less I think Michelle came to me with was something like, what can we do about climate change? But in order to try to make sense of that question, I think that we need to step back and ask what is causing climate change before we can kind of say what can we do about it. And then before that, we kind of have to get on the same page about, is climate change even a thing, which is an open question depending on kind of what circles you're in. And there's a more general, broad type of question, which is how have humans impacted the environment that we have to kind of make sense of. And so if we step back even further, we get to kind of how do we know anything about anything? So that's where we'll begin, and I'll throw it out to you guys. Shout it out. How do we know anything about anything? Shout it out when you know it. How do we learn about the world around us? Science is the correct answer. Science is how we learn about the world. And one way of thinking about science is that it's a set of topics. So if you take a science class, you might take a class that's in one of these fields, one of these subjects or these topics. But a better way to think about science is that science is a way of learning. So you can use science in a lot of different directions. And so maybe some topics that you might think of as social sciences, but even things like car repair are scientific if they use a scientific process where you make predictions and you test those predictions and you use evidence. Ultimate fighting. Do we currently, Smalley, can you tell me, do we have a wellness section that focuses on ultimate fighting at the moment? This is something to work on. But if you want to know which martial art is best, you just try all the martial arts against each other and then you find out. So there's a lot of ways of thinking about science. There's a lot of kind of philosophy of science we could talk about. One maybe way to think about it is as a culture with a set of norms. So there's a whole sociology of science to think about. So what is the culture of science? It's that arguments are always ongoing. Nobody gets to say this discussion is finished. Anybody gets to be involved. And if you want people to believe you, you have to show them evidence and you have to convince them, you have to persuade them. There's a role for discussion. You have to be open to hearing different perspectives. This is the culture of how science works. There's a competitive nature where people are trying to disprove each other. People think that they're right about something, but they have to show evidence and convince others. A Nobel Prize-winning economist, really a psychologist, but his Nobel Prize is in economics, Danny Kahneman, pointed out it is much easier and far more enjoyable to identify and label the mistakes of others than to recognize your own. This is a truth about human psychology, and this is the reason why we need competitive communities to try to prove each other wrong. So that's a real brief kind of overview of what science is like and how science works. There's much more we could say. We might be raising more questions today than we answer, but let me know. We can follow up and talk more about any of these things. So how have humans impacted the environment? Let's begin with the last ice age. So at the end of the last ice age, the northern part of North America is covered by ice sheets, and this extends down into the Northeast and the Great Lakes and parts of the kind of northern plains. So New York and Boston are under a mile of ice at this point. And at this moment in time, there is an incredible diversity of giant mammals that live here, right here, and this includes things like giant mammoths and mastodons and woolly rhinos and giant bears and giant wolves and saber-toothed cats, giant lions, horses, camels, giant sloths, all kinds of incredible stuff. And this is the world of here, but a little while ago with, giant saber-toothed cats, taken out camels, driven off by these packs of giant wolves. And this was an era of the American lion, which is a larger creature than today's African lions, taking down wild horses that used to live here with giant mammoths and stuff in the background. And we have fossils and tar pits and all kinds of records of all these creatures. But this is the world that when modern humans arrived, crossing over from Asia into the Americas. This is the world that they encountered. And again, we have lots of records of modern humans arriving in various locations in the neighborhood of last 20,000 years ago or so. We have lots of cool records. This was just published a couple years ago. These are footprints from New Mexico dated at 21 to 23,000 years ago. So you've got real clear evidence of people walking around. So when did humans arrive, and what was the world like when they arrived in the Americas? So we go from this world of these giant mammals 20,000 years ago. Humans arrive, and by 10,000 years ago, all these giant mammals are gone. And you might reasonably ask, what happened? We can kind of zoom out and we can move around the globe where we've got all these cool big creatures in the Americas that go extinct. A lot of the smaller ones stick around. If we move over, where in the world are we here? This is Australia, so a different part of the world, different period of time. This is another 20, 25,000 years previously to the peopling of the Americas. And we see that there used to be huge, gigantic, fantastic marsupials, giant wombats and huge, crazy kangaroos and things. And a bunch of them go extinct. And so there's a pattern which starts with the human colonization of Australia, which leads to the immediate extinction of all the cool giant marsupials. And every human colonization where humans were not before gets followed by a wave of extinction of these large animals. So this is true not just in Australia and North America, but South America and Madagascar and islands in the Mediterranean, the Hawaiian Islands, the islands of New Zealand, dozens of Pacific islands. This is a trend that happens wherever humans show up in the recent past. All the cool big mammals go extinct. So this modern humans emerge from Africa. They people the Middle East and Europe and South Asia and East Asia and the Americas. And we get these mass extinctions everywhere just when people happen to turn up, right? So it seems unlikely to be a coincidence. And one of the kind of beautiful pieces of evidence for the fact that people coexisted with these creatures is that they painted them. So we have these great cave paintings, especially in Western Europe. This is in Spain, but also in South America. So this is one of those glyptodonts, one of these giant armadillos, in a cave painting from about 12,000 years ago. So people interacted with these things, they painted them, and we still have those records today. So giant cave lions, people drew these on cave walls. The giant cave bears that we talked about. The woolly mammoths. We still find, as the permafrost is thawing in the Arctic, we still find carcasses of dead mammoths. People drew them, these giant woolly rhinos that people drew in their cave paintings. The wild horses that then went extinct. And cool giant deer. And interestingly, we know even that these creatures were hunted before modern humans arrived in Europe. There were Neanderthals in Europe, or Neanderthals, depending on whether you want to go with the German or the American pronunciation. And even before that, we had a previous species, Homo erectus, running down and hunting large animals as well. So you go back in time, this is a site in the Middle East, with Africa down here to the southwest, and Central Asia here to the northeast, and to the northwest Europe. And so right in this central area, we can look back in time in the fossil record, and we can see when modern humans were around, when the Neanderthals were there before them, and Homo erectus before then, we have larger and larger mammal fossils in these layers. And as time goes on, the giant mammals disappear over time. So this clear evidence of humans over-hunting these species to extinction. So what is different in the world of today is that we have knowledge of this, right? There was no knowledge in the past of things like human impacts on the environment. And we have things like global agreements to protect biodiversity. This is a new thing in human history. There was never global agreement in the past, right? People were all disconnected from each other. So just in the past 30 to 40 years, we've taken extinction rates that would have been 3 to 4 times higher and saved dozens of different species from extinction. So we have lots of conservation success stories. If we look just in Europe, we've got things like populations of elk and whales and bears and seals that have increased by tens of percent to 100% increases in badgers, hundreds to 1,000% increases in all kinds of other wild species, up to 16,000% increases in bison and beavers in Europe. So we have these incredible success stories But none of this happened on its own. None of it happened for free. It happened because we cared about it, and we invested the time and energy in gathering the data and then acting on that data, and doing something because we made it a priority. So when you think about human impact on the environment, we can look at things like land use. So as coming out of the last ice age, we've got a lot of forest and a lot of grassland. And then as agriculture proceeds, the Industrial Revolution, human population increases, more and more forest gets turned into cropland, and more grassland gets turned into grazing land. So we have this loss of habitat. This is an ongoing problem. But, again, if we look at the data, how much land do you need per person for agriculture to function? And over the last 2,000 years or so, that number has remained the same, which is 1.5 hectares or so per person. But spectacularly, just in the past century, the amount of land per person needed for agriculture has plummeted. And so this number has halved. Even as we have continued to make more food for more people, we use less land per person to do it. This is an incredible achievement. And so historically, as you increase the agricultural output, you had to increase the amount of land being used to increase the agricultural output. And then we get this fantastic crossing of the lines just within the past 15 years, where we continue to produce more and more food, but using less and less actual land for it. So there's the opportunity to use our knowledge of the world to improve and lessen the human impacts on the world, right? In terms of things like land use that's being turned over from natural environments to agriculture. You guys probably don't hear much about acid rain anymore. This used to be a huge problem. And we identified the problem, we identified the cause of the problem. We came up with strategies to prevent that problem. The problem is when you burn fossil fuel, you release sulfur dioxides and nitrogen dioxides, and this produces acids. So what do? You regulate the production and the release of those particular pollutants. And you do this by saying if you have a coal plant, you got to use scrubbers on your smokestacks, use less coal, use more natural gas, use more renewable energy. This doesn't happen on its own. Companies don't just decide to do this. We have to make it a priority. We have to make a law that says that you can't release these pollutants. And this is how we create progress in terms of humanity and our impact on the environment. And so if you look at how this happens, there's the formation of an environmental protection agency. This happens in the 1970s. And by making these laws around pollutants, we have today's cars that are 99% cleaner than the cars of the past. It didn't happen on its own. It didn't happen for free. We had to make it a priority. So if you look at the concern about acid rain in the pH of rain in the eastern third of the United States, in the late 80s, in the early 90s, in the mid 90s, we see a lot of acid rain. And as these laws take effect, you see the pH of the rain in the eastern US becoming less and less acidic. And when we roll over back to the 80s in our clip here, you can see this dramatic difference in the quality of the air, right? It's happened because we cared and we invested in it. So how about the ozone layer? We don't probably hear too much about this. This used to be a bigger concern, and the hole in the ozone layer has stabilized within the last 10 to 20 years. And why did this happen? We identified the cause of particular chemicals and acted on that to create laws, and the result is that now these particular kinds of things like chlorofluorocarbons and tetrachlorides and so forth, these have declined by more than 99% just in the last 30 years or so. It didn't happen on its own. It happened because we used the existing framework of the Clean Air Act and the Environmental Protection Agency, and we made laws that said you can't release these particular pollutants. And the result was cleaner air, right? So where does that leave us? Who knows? Okay, climate change. That's our human impacts on the environment, big picture. So climate change. Is climate change happening? This is a news article from almost exactly a decade ago. Inhofe brings snowball on Senate floor as evidence globe is not warming. Actual article about an actual moment in time. Senator James Inhofe, Republican of Oklahoma, who strongly denies that climate change exists, brought a snowball on the Senate floor as an example that the globe is not warming. Inhofe, the chairman of the Environment and Public Works Committee of the Senate. So you guys are college educated. Why is there winter? Shout it out when you know it. The Earth spins, and does it spin upright? What is it like? It is tilted on its axis. And what that means is that sunlight that hits these angled surfaces of the Earth are less direct. And so not only does the Earth rotate about its axis, what else does it do? Shout it out when you know it. It revolves around the sun. And because of the tilt of the axis, during part of the year, the northern hemisphere is tilted toward the sun, and sunlight hits our part of the Earth more directly with more energy per unit area. And and what do we call that time? Shout it out when you know it. Summer is correct. And then during part of the year, the northern hemisphere is tilted away from the sun. It's actually physically closer to the sun, but tilted away. And what do we call that period of time? Winter. And so the northern hemisphere goes through these predictable cycles. This is satellite data from NASA. And you can see a cold period that we call winter, a warming and greening period as we get into summer, and this cyclical progression through the seasons as we go through the year. The southern hemisphere is offset in terms of its winter and summer. But even though there are seasons, and even though it's cold right now, what global warming means, or climate change more generally, is that if we look at the last couple hundred years of climate data, we see that it's colder in January and warmer in July consistently. Seasons haven't gone away. But what has changed is, as we go from these paler colors to these darker, warmer colors, is year after year, decade after decade, century after century, more recent years, the Januaries are warmer than they used to be, and the Julys are also warmer than they used to be. So that trend of warming hasn't eliminated the seasons, but it represents a change in the Earth's climate. So if you look at Julys from the late 1800s to now, Julys are getting warmer. And if you look at Januaries from the late 1800s to now, Januaries have been getting warmer, even though the Januaries are still colder than the Julys. And if the climate is warmer, what that means for things like sea ice, we go through these predictable periods of more sea ice, January, February, March, and then as this, in the Arctic in the northern hemisphere, as the climate warms seasonally, we get this drop in sea ice, but we're losing sea ice at more than 10% per decade, consistently year after year. So we take what used to be big extents of Arctic sea ice, and we're moving toward an ice-free Arctic, which in human history has never happened before. So pretty spectacular changes. You can look at things like glaciers in Alaska, and you say, here's a picture from a century ago, where this whole valley is filled with this river of ice. There wasn't a valley there in the past. The glacier carved it by flowing through it and dragging away the rocks. And you go back to the exact same spot and you take a picture. This is now 20 years ago. But all of this glacier has melted away and this glacier has receded. This is a global pattern that is consistently happening worldwide. When you look at different temperatures, 2016, hottest year on record, 2020 ties it. 2023 breaks the record for 2016 and 2020. We just what year did we just finish? Shout it out when you know it. 2024. 2024 was the hottest year in the past 100,000 years. And so we can look back, and this is just the last 24,000 years. We see coming out of that last ice age, that last glacial maximum, the climate warmed over a period of thousands of years to get up to our kind of modern temperature we've had for the last several thousand years. And it's just in these past couple centuries that we've had this rapid, unprecedented spike to a warmer climate than has existed for much of the recorded past. So to kind of sum up a lot of different pieces of information, we've got a warmer last decade than we've had for more than 100,000 years. Glaciers retreating faster than they have at any time in the recent past. Sea levels rising as a result. Arctic ice lower than it's been. Oceans warming, becoming more acidic as they absorb more carbon dioxide. And this idea of carbon dioxide we'll kind of come back to. So that's a brief attempt to say, what do we know about, what's the evidence that suggests that the climate is changing? We have a lot of different pieces of information. So what is causing climate change? And it's worth acknowledging that not everybody agrees about what is causing climate change. So if you ask people who vote Democrat, or people who vote Republican, or people who identify politically as independents, you say, is the increase in the Earth's temperature caused by pollution from human activities? And over the last 20 years, you go from about 5 out of 10 people who vote Republican agreeing with that to less than 3 out of 10. Whereas you've got from 7 out of 10 people who vote Democrat to more like 9 out of 10. So we have this partisan split, and this is reflected more broadly in just the question of, do you trust science? Do you have a great deal of confidence in science? And if we look into the past, we find for the 70s through up until really the early 2000s, Republicans, people who vote Republican, consistently trust science more than people who vote Democrat. And then we get this crossing of the lines here in the early 2000s. And about 1990, Republican voters' trust in science has been on a continuous decline. And a little bit later, maybe in the early 90s, we've got this continual increase in trust in science. So ideally, we want a world where whether you trust science is independent of your kind of political perspective. But in the past, that has not been the case. And in the current moment, something happened, something maybe like around 2016, there was this dramatic split where trust in science becomes part of people's political identity, which is a problem. It's not that these people understand science more, it's just a way to distinguish ourselves from each other. So that's maybe a topic for another time, but we'll acknowledge that. But what is causing climate change? We have a pretty clear idea. So this is a biogeochemical cycle. These exist for various nutrients. There's a water cycle and a nitrogen cycle, and there's a carbon cycle. And the amount of carbon that's going from the atmosphere to the oceans is about balanced out by the carbon leaving the oceans and going to the atmosphere. The same thing for photosynthesis and respiration on land. And what's different than in the past is burning and fossil fuel burning and some kinds of, what do you call, making stuff in a factory kinds of activities, right? Industrial activities, as well as a little bit of altered land use. But we have huge amounts of fossil fuels that are locking up carbon buried underground, and when we extract those fossil fuels and burn them, then we upset the balance of this carbon cycle. So carbon dioxide is not the only, what we call a greenhouse gas. There are things like methane and nitrous oxide and things like this. And there's release of carbon dioxide from other events, but burning of fossil fuels is really the bulk of how we have increased concentrations of carbon dioxide. So what else do we have here? So what is the greenhouse effect? You guys ever been in a greenhouse? What's it like? It's warm or hot. It traps the heat. And this is what the atmosphere does. This is why we call it the greenhouse effect. Energy from the sun, we've already talked about that, hits the earth. Some of it escapes, but some of it is trapped. And the more greenhouse gases in the atmosphere, the more trapped heat from the sun we have. So it's a fairly straightforward idea. And in fact, we have known of this for 130 years. A couple of Swedish scientists did the calculations at the end of the 1800s and correctly predicted what would happen if you doubled the amount of carbon dioxide in the atmosphere. What would that do to global climate? So we have known about this for more than a century. If people are interested in sort of how do we have this relationship between carbon dioxide and temperature, we can take ice cores from Antarctica. And we have records over the last 800,000 years, and you can see in red the concentration of carbon dioxide goes up and it goes down. And here in black, we can measure a proxy for the temperature from an oxygen isotope analysis. And we see when there's more carbon dioxide, we have higher temperature. And less carbon dioxide in the atmosphere, lower global temperature. So a very close relationship between how much carbon dioxide in the atmosphere and what is the global temperature. And we, again, tools of science, blah, blah, blah. You can look at the Antarctic, make predictions about the right places to drill. So we've been talking for years about being able to get an even longer sequence of Earth's chronology, and just about a month ago was announced this 1.2 million year ice core that's 3,000 meters long that we've been waiting for. This was 10 countries. This was a global operation. And here's a section of this ice core. So bubbles of air, which include oxygen and carbon dioxide and nitrogen, are trapped in the ice. We have this long unbroken record of Earth's climate. It's pretty spectacular. So that brings us to what can we do in the time that we have left, which is no time, and what can we do about climate change? Let me know if you want to follow up more about this stuff. We'll just kind of fly through it. Should we be worried about climate change? Yes. Should we despair and give up hope about climate change? No. Journalism, there's a problem of negativity in journalism. We would talk about that if we had time. And what are the kinds of things that we should be doing? We should be, world has gotten better. We would talk about that if we had time. Life expectancy has gone up, and child mortality has gone down. And these things will continue to happen. Climate change is not going to end human progress, even though some people have this concern. So that brings us to a lot of positive news in terms of more use of renewable energy, less use of coal. We've already gotten to the point where maybe this year we peak the global use of coal, and then about a decade later, our use of oil will also decline. So we have less emissions now than we've had in the past. Even for the last 50 years or so, the US and Canada have been producing less emissions per person. So that's good news and improvement. And even as we've continued to become wealthier as societies, poverty is going down. So we've been able to decouple emissions from economic growth. So we need countries to become wealthier. Wealth leads to better outcomes. We would talk about that if we had time. So what needs to happen is less coal and more clean energy, and processes like aviation and steel production to become less carbon emittive. But more electric vehicles is better. Less food waste is better. A changing diet that has more plants is better. More public transportation and walking and so forth. So I'll leave you with a Calvin and Hobbes strip that mentions this idea of doing what you can with what you have. Sometimes you feel like you're in the tub, you have no resources. You can't personally end climate change, but you can contribute, and your contributions are valuable. So that's what I will leave you with. Thanks. Let me know when you have questions about stuff. We can talk about it. See you guys.
Thank you so much, Kyle. We are going to get the attendance out. Remember that you get onto Moodle through your browser. Get on Moodle through your browser. And if it doesn't work the first time, try about 10 more times. And little joke. And we're going to get it. Yeah. Thank you. And thank you again, Kyle. That was fantastic. Thanks. It'll be coming up here in just 1 second, I think. Thank you.